Alright, welcome to this video, and in this video we're going to be looking at differential equations. Now, when we look at differential equations, the different types of differential equations, and we're going to look at how to get the order and degree of a differential equation. Now, for a differential equation, it's just like any other equation, but the difference is that a differential equation has a differential coefficient, right? So now, for a normal equation, something like 2x minus 5 equal to 0. These are the equation because of this equal to symbol that we have here. And now if we were to solve this equation, we're going to have 2x is equal to 5, then x is equal to 5 over 2. Now this is the solution of this equation. Now this is a normal linear equation. Now, but for a differential equation, I said that a differential equation is an equation that has a differential coefficient. And for by differential coefficient, we mean things like the y, the x, the v square, oh sorry, the square d, this. We have the y dx, we have the square v over the v square, right? And then we have equations, we have different coefficients like y prime prime, we have f prime of x. So whichever of these that you see, there are many more than this, you can basically form any differential coefficient of your choice, right? But just that the idea is that this kind of things, right? When you find the derivative of an equation, maybe once, twice, three times, four times, even 100 times, it forms a differential coefficient, right? At the moment you see such differential coefficients in an equation, then it becomes a differential equation. One of such differential equations is dy dx is equal to 2x. So now this is an example of a differential equation, right? And because it has a differential coefficient, right? So now we have different two types of differential equations. We have the ODE, which is the ordinary differential equation, and then we have the PDE, which is the partial differential equation. Now, what is the difference between an ODE, an ordinary differential equation, and a PDE, a partial differential equation? The difference is that for ODE, it involves only one independent variable, right? So just like the equation I wrote earlier, y dx is equal to 2x, it has only one independent variable. In this case, it is the y dx. This is the independent variable. It has only one, right? But when it comes to PDE, they have more than one independent variable, right? From two and above. An example is the y dx is equal to 2x plus the v dx. Now we can see that we have an independent variable here and we have another independent variable here. So we have two independent variables, and that is what makes it a PDE, a partial differential equation. That is for differential equations, and so that those are the two types of differential equations, and how we can identify a differential equation. Right, the moment we are able to locate a differential coefficient, then we know that it is a differential equation. So now we're going to look at the order and the degree of a differential equation, right? So the order and degree of a differential equation, how can we locate or how can we determine what is the order and degree of a differential equation? One thing I'll have you know is that you cannot find the degree of a differential equation without finding its order, right? So order and degree of a differential equation. Now, for instance, this equation I wrote earlier, the y dx is equal to 2x. Now, if we were to find the order and degree of this differential equation, the only thing that we need to do is first find the order, then we find the order, then we're able to find the degree. Now, how do we find the order? The order of the differential equation is the highest differential coefficient present in the equation. Now, if you look at this equation, we have just one differential coefficient, right? And that is dy dx, right? Dy dx is the only differential coefficient. So we're going to get our order from this differential coefficient. Now, how do we get the order? The order is basically how many times you differentiated to arrive at that differential coefficient. So in this case, dy dx we just differentiated once, right? So since we differentiated once, the order is 1. And then the degree is basically the power of that differential coefficient, right? So the power of this differential coefficient is 1, right? Because the y dx by 1 is still the y dx. So it's obviously 1. That is the degree of the differential equation. Now, but the plot twist here is that for degree of a differential equation, right, you cannot get the degree of a differential equation if you have a radical or you have a fractionated power in the differential equation. What I mean is by radical is, let's say you have dy dx raised to power minus 1 equal to 2x. You must first eliminate this minus 1, right? And to do that, all you have to do is just um, you can do it in many ways actually, but you can dy dx is power minus 1 is going to be 1 over dy dx, right? And this goes to 2x, and then you can cross multiply. So the moment you are able to eliminate that negative power or you eliminate a fraction, right? So let's say we have dy dx and then we have squared equal to 2x, so 1 over 2. Now, if you want to eliminate this fraction, you cannot say the degree of this differential equation is 1 over 2. You would be wrong. So to get the degree now, you have to square both sides, right? You square both sides. So these two we cancel this and then we have dy dx is equal to 4x squared. And now we can get the degree of this differential equation to be 1, right? So the idea is that you cannot get the degree of a differential equation if the power of that if there is a power that is in fraction or a power that is a radical, basically. So we're going to look at two questions so that we check how we can fish out the order and degree of differential equations. Right. So now for an example, we have L d square Q over dt squared plus R dq dt plus Q over T is equal to E sine Wt. So now we have this differential equation, and we know it's a differential equation because it has differential coefficients, right? It has two in this case. It has this one and this one as opposed to the first question that we did. So now, how do we know which one is the order and degree? Remember, I said that the order is the highest differential coefficient present in the equation. So which one is higher between d square q, dt square, and dq dt, right? This one is higher, right? Because we have differentiated twice. So that means our order is going to be 2 because we differentiated twice. And then the degree is going to be the power. And here we can see that there is no power here. So that means automatically it's going to be 1, right? Because d square q dt square raised to power 1 is still d square q dt square. So that means the degree is going to be 1 for that differential equation. So now, a question that you might be wondering or might be asking is, for instance, we have another independent variable, or maybe it's a partial differential equation that we have d raised to power 4y over dx squared. Imagine we have this in this question, right? And it looks something like this: d square q over dt squared plus r dq dt plus d raised to power 4y dx squared. This is 4 is equal to E sine Wt. So how do we find the order and degree of differential equation in this equation? The order and degree of differential equation in this equation. So now, would you say because this differential coefficient is not the same as these two, because these two are gotten from the same source, right? And this one is dy dx, right? And this one is dq dt. Would you say that you would not pick your differential your order and degree from this one? No, right? You always look for the highest regardless of whether it is the same or not. So because d4y and dx sorry, this was to be 4 as well, right? D4y and dx to the power 4 is the highest differential equation coefficient in the question. So that's where you're going to get your order and degree from, right? So your order here is going to be 4 because obviously we differentiated 4 times to arrive at this point, and then our degree again is going to remain 1 because this is only raised to the power of 1, right? And now we're going to look at one more question. All right, so now um right, so this question is 1 plus dy dx squared raised to the power 3 over 2 is equal to d square y over dx squared. Now we're asked to find the order and degree of this differential equation. Now remember, I told you earlier that when you have a fraction as the power, right, you cannot get your degree. So you have to first eliminate that fraction. And to do this now, what we're going to do is we're just going to square both sides. So 2 we cancel out to here. And then we have 1 plus dy dx squared. Then we have raised to the power of 3 is equal to d square y over dx squared. Then we have squared here. So now we don't have any fraction as power, we don't have any radical as power, we can get our order and degree. So now, if looking at this equation, which differential coefficient has the highest, which one is the highest differential coefficient? It's going to be d square y over dx squared, right? And the same differential coefficient that you get your order from is where you're going to get your degree, right? So you cannot get your degree, your order from this one and can't get your degree from another one, regardless if the power of the second differential coefficient in the question is higher than what the one where you got your order from is, right? So for this one now, we differentiate twice. So our order is going to be 2, and the power, as you can see in this question, is 2, right? It is squared, so your degree is also going to be 2. So that is all for order and degree of differential equations.